This question, we are given a function and we are told that it has factors of x plus 1 and x plus 2. And here we are not given values of a and b. We need to work out these values. So from the factor theorem, we know that if x plus 1 is a factor, then if we substitute in f of minus 1, it will equal a 0. So we can say 0 equals a times minus 1 cubed plus 5 times minus 1 squared minus 6 times minus 1 plus b, which implies that 0 equals, well, minus 1 cubed is minus 1, because it's minus 1 times minus 1 times minus 1, so we get minus a. Minus 1 squared is positive 1, so that will be 5. Minus 1 times minus 6 is plus 6, and we've got plus b at the end. So that will imply that 0 equals minus a plus 11 plus b. And we can leave it like that for now. Let's look at the other factor, x plus 2. Well, from the factor theorem, if x plus 2 is a factor, then f of minus 1 minus 2 even equals 0. So let's put minus 2 into this function here and then see what we get. So we have 0 will equal a times minus 2 cubed. I'm going to put that in brackets just to remind us that we are not just squaring the minus 2, sorry, we're not just squaring the 2, we are squaring the minus 2. And we've got 5 times minus 2 squared. It's just said cubing the minus 2 there. Minus 6 times minus 2 plus b. Okay, let's work that one out. We've got 0 equals, now minus 2 cubed is actually minus 8, so we'll have minus 8a. Minus 2 squared is 4 times 5 is 20, and we get minus 6 times minus 2 is plus 12 plus b. So in this case, 0 equals minus 8a plus 32 plus b. Now we've got equation 1 here, and we've got equation 2, and we can solve these simultaneously. We'll probably just need to rearrange them slightly. Just for form's sake, I could rearrange them. I don't have to, because I'm looking at these and I'm seeing that if I take one from the other, the b's will disappear. So I could say, for example, by elimination, 1 take away 2. So if I set out 1, and I can set it out as it is, it doesn't matter. Just need to be careful of my signs here. Minus a plus 11 plus b. So that's equation 1. And equation 2 is 0 equals minus 8a plus 32 plus b. I'm actually looking at this now and I'm thinking maybe I could have done the other way around. That might have been easier, but let's keep it as it is. 0 take away 0 is 0. Minus a minus 8a is, this becomes plus 8a, so we end up with plus 7a. Now, just a tip here, if you get confused with this or you just want to double check, it's no problem to take it to the aside, and you could say minus a minus 8a, and there we can see that that becomes minus a plus 8a, which equals 7a. Okay, 11 minus 32, that would be minus 21, and of course b, take away b, is 0. Already here I can kind of sense I'm on the right track, because taking the 21 onto this side, we get 21 equals 7a, which would mean that 21 divided by 7 is a. As I say, I'm on the right track here because 21 goes precisely into, so 7 goes precisely into 21. 21 can be divided by 7 with no remainder. So I know that a equals 3. I can put it back into one of these equations. Let's try equation 1. I'm only picking that one because the numbers are smaller, but I could have picked equation 2 here. And let's see, we have 0 equals minus 3 plus 11 plus b. And so I would get, well, minus 3 plus 11 is 8 plus b. So b will equal minus 8. And of course I can check this now by putting both of these values into my other equation here and making sure that it works. So let's just do that quickly as an aside, and I'm going to write check here. So my check is 0 equals minus 8 multiplied by my value of a, which is 3, plus 32 minus 8. And let's see if that works. So I will get 0 equals, or minus 8 times 3 is minus 24 plus 32 minus 8, and that does indeed equal 0. So my two answers here, 21 over 7, which is 3, and my other answer here of minus 8. Let's just put that back into my, what I'm given here as the function, and so that then would be f of x equals, so it was ax cubed, so it would be 3x cubed plus 5x squared minus 6x plus b, so minus 8. And that's my answer.